Hello everyone, I am Anjan and welcome to the 5th video tutorial of the Verilog course series. In this video, you will be getting to know how the full subtractor works and how to design a Verilog code for full subtractor using the instantiation method and gate level modeling. For better understanding, I split the video into 3 parts, that is pre-coding part, coding part and the post-coding part. Now let's move on to the pre-coding part. In the pre-coding part, you will be seeing the circuit diagram and the truth table, and I will be focusing on the circuit diagram in this video to design the Verilog code. And in the circuit diagram, if you saw my previous video about the half subtractor, you can say that this is using 2 half subtractors in the circuit diagram, which is this part and this part. This XOR NOT and AND gate comprises of one half subtractor, and this XOR NOT and AND gate comprises of another half subtractor. And finally, these two is connected to one OR gate, and this results to the borrow, and this results to the difference. Now I will be instantiating the XOR half subtractor which I used in the previous video. Now let's move on to the coding part. Here is the Verilog code for half subtractor, and I explained the code for this in my previous video. You can check out it in my Verilog course series. Now I will be going to the full subtractor. Here I taken A, B and B in as the inputs and D, B out as my outputs. And I declared D0, B0 and B1 as wire. And what are these variables? I will be explaining in the circuit diagram. Let us consider this is one half subtractor where I will be giving where a half subtractor will have two inputs and 2 outputs. Here the 2 inputs are A and B, and the outputs are just wires. You can see it. So I declared it as wire and I given the name as D0, B0. And here also I will be giving another name, that is B1. This is another half subtractor, and we will be getting the another wire here as an output, and I will be giving B1 as the name for it. Okay. D0, B0, B1. And I given here as reg B out. Just I have just given it, just didn't make in the coding part. I have changed it. No worries. You just forgot about this statement. I just comment out in. I will comment out it. It is no requires. Now coming to the instantiation part, I instantiated half sub. This is the module name I used in the Verilog code for half subtractor, and I taken 2 inputs X and Y, and diff and borrow as an outputs, and these 2 as an inputs. I will be using these names for instantiating. Here I declared my module name for half subtractor is half sub 0 for the subtractor 1 and half sub 1 for the second half subtractor. I given dot x because in the dot x means it is in this half subtractor, and inside the bracket the element will be included to this element x, and the b will be given to y, and d0 will be given to diff, b0 will be given to borrow. Now if you observe the circuit diagram, you will be knowing that the result of the first half subtractor will be D0. That will be giving as an input to the half subtractor of the second half subtractor, and the output of the second half subtractor will be the answer, that is difference. and the output, the bar output of the second half subtractor will be given to the input as to the OR gate, and you will be getting the bar as an output after the OR gate process went. Here is it. I given A and B as an inputs, and I am getting the D0 wire as an difference output and B0 as an output bar. And I given this D0 here in the second half subtractor as an input, and here is the B in, which is the other input given to the second half subtractor, and I will be getting the answer D output. And the borrow B1, which will be giving, these two borrows will be giving to the OR gate as an inputs, and we will be getting B out as the answer. And here I ended the module. Now let's move on to the pre-coding part. Post-coding part. Here I just copy pasted the whole code. Here you can see that I just didn't return the reg B out. Sorry. Here I commented it on now. I just didn't return there. To save the time, I already simulated it. To check this, we have to go to the truth table. I will be considering three conditions, that is 0, 0, 0, so that the output will be 0, 0, and the second condition is 1, 1, 1, so that the output will be 1, 1, and third condition is 1, 0, 0, so that the output will be 1, 0. I will be giving the inputs. Here I will be running it. Here I got all zeros. That is, you should concentrate on D. This is the output, and B out. This is the output. You can see that it is both are zeros for the inputs three. For the three inputs 0, 0, 0. Now I will be changing it to 1, 0, 0, so that I will get 1, 0 as an output. Here I got it, 1, 0. Now I will be giving 1, 1, 1 as an input. So that I will get 1, 1 as an answer output. Here I got it, 1, 1. I will be zoom fit it to see the whole circuit, whole graph. At 0 instance of time, I didn't give any inputs, and 1 microsecond I given the inputs as 0, 0, 0, so that I got the answer output as 0, 0. At 11 microseconds I given 1, 0, 0, so that I got 1, 1 as an output. Next, at 21 microseconds I given 1, 1, 1 as an input, so that I got 1, 1 as an output. You can saw D and B out here, whereas here you can find D and B out here. Okay, now I will be showing you the schematic. Here you can see the schematic of the full subtractor, where here two half subtractors is used, and these two are connected to the OR gate, and you can getting the B out as an output. And you can find the circuit for half subtractor 2, which I zoom in. Here is the half subtractor circuit which I have used in my previous video, and this is the circuit. If you like the video, do like, share and subscribe to the Start Scratch. And if you want to explore the Verilog circuits and codes, do check out my videos on the Verilog code series. Enjoy learning. Thank you.